The cucumber smell isn't coming from a shark, it's coming from the ocean dying around one. The cucumber-like scent in open water is most likely a spike of dimethyl sulfide, DMS, a gas formed when phytoplankton die or are consumed by zooplankton, releasing a compound that bacteria convert into DMS. A sharp, sweet, vegetable-like smell over open water means something just triggered a mass die-off of microscopic life, which happens when a large predator has been moving through that zone, disrupting the water column. You're not smelling the shark, you're smelling everything that died when it passed through. Sharks are literally leaking a chemical that humans can detect, and scientists have only recently understood why. Sharks routinely retain bodily concentrations of urea that would kill most other vertebrates. To counter this, they carry even higher concentrations of TMAO, trimethylamine oxide, which stabilizes proteins against urea's toxic effects. Together, urea and TMAO make a shark's internal fluid slightly saltier than seawater, and this leaks passively through their gills and skin into the surrounding water. TMAO in its raw form smells faintly sweet, like cucumber or melon. The larger the shark, the more it leaks. You can, in theory, smell a big shark's presence in still water before you see it. Sharks absorb ammonia through their gills and release it too. Research from the University of British Columbia found that sharks can absorb ammonia from the water through their gills at high rates, converting it into urea. The amount absorbed could account for almost a third of the nitrogen they need from their diet. This is a two-way system, meaning in calm, enclosed bays or coves with low current, a resting shark isn't just absorbing, it's also releasing chemical byproducts. Still, enclosed water that smells faintly of ammonia or sweet decay around low tide is one of the least talked about warning signs in coastal swimming. The cuttlefish figured out how to weaponize the shark's nose. Science only just confirmed it. A 2025 study from University College Dublin found that melanin, the primary component of cuttlefish ink, can overwhelm a shark's sense of smell, causing it to avoid areas where the ink has been dispersed. By modeling the 3D structures of shark olfactory receptors using genetic data from multiple shark species, including the great white, researchers discovered that melanin's molecular structure lets it physically latch onto the smell receptors, disrupting the shark's sensory perception entirely. A cuttlefish has been chemically jamming the ocean's apex predator for millions of years, and we only found out in 2025. Sharks share almost identical smell receptors across all species, which means one chemical affects them all. As sharks generally share the same core set of olfactory receptors across different species, regardless of different habitats and lifestyles. Any natural deterrent that works on one shark's nose has the potential to work across the majority of shark species.
The only animal that can unlock this predator.
For all sharks, and the cuttlefish already holds the key. It also means that a specific chemical signature in the water, whether DMS, TMAO, or something released by stressed prey, is read the same way by a great white, a hammerhead, and a tiger shark. Up to 18% of a great white's brain is dedicated to smell, the highest percentage among all sharks. Sharks smell in stereo. They detect tiny delays in the time it takes a scent to reach one nostril compared to the other. It's this lag that tells them precisely which direction a smell is coming from, allowing them to home in on the source with speed and precision. This means when you leave a chemical trail in water, the sunscreen, sweat, certain foods, the shark doesn't just know you're there. It knows exactly which direction you're in and how far you've moved. The sea smell that guides birds to food is also the smell that marks shark hunting grounds. Seabirds use the scent of DMS to track blooms of algae near the ocean's surface, where microscopic animals, krill, and crustaceans gather, providing a reliable food source. Sharks know this too. Dense DMS plumes mark feeding zones, areas of high prey density where sharks actively hunt. A patch of ocean that smells unusually strong of that sweet, fresh sea air over open water isn't just pleasant, it's a chemical marker that tells every apex predator in range that prey is concentrated there. That distinctive vacation smell can be the exact scent of an active feeding zone. The peacock soulfish has been weaponizing shark noses since World War II research and causes tonic immobility. Pavoninin-4 is an ichthyotoxin secreted by the peacock soulfish to repel predators. It was researched in the wake of World War II as a potential shark repellent. It has been shown to cause a state of tonic immobility when introduced into the nares of the lemon shark. Tonic immobility is essentially a state of paralysis. The shark flips upside down and becomes unresponsive. A flat, unassuming fish on the seafloor carries a chemical in its skin that can shut a shark's entire nervous system down through its nose. And the ocean floor is full of creatures running this same chemical war that humans have barely begun to map.
The ocean smells good for a dark
is actually
reason.
a signal of mass death, and more of it means something is collapsing. The distinctive sea breeze scent is the smell of DMS produced when marine algae are stressed, consumed, or dying. DMSP, the precursor to DMS, functions as an osmolyte and antioxidant, protecting algal cells against stress from salinity or light. When algae release it, they're under attack or dying. Marine algae produce an estimated 10 to 35 million metric tons of atmospheric sulfur through DMS every year. The beautiful, nostalgic smell of the ocean that people associate with holidays and freedom is, at a molecular level, the exhaled, dying breath of trillions of microscopic organisms. And the stronger it is, the more is dying below you. Sailors used the smell of the ocean to navigate toward land for generations, without knowing what they were smelling. For generations of mariners, a tangy, almost sweet odor served as a signal that land was nearby. What sailors called the smell of the shore guided them toward coasts before they could see them. They were following DMS, the chemical released by algae blooms concentrated near coastlines and reef systems. The same smell that told a 15th century sailor, "land ahead," is the same smell that draws sharks to feeding zones, that guides seabirds to prey, and that spikes sharply when large predators move through an area. The ocean has been sending this signal for millions of years. Humans just thought it smelled nice,